The last biogeochemical cycle that we need to look at is groundwater, or I'm sorry, the water cycle. So first we have to understand where water is found. The oceans are the primary reservoir or primary sink for water in the earth. And all of the processes of the water cycle are driven by the sun. Our secondary sink with the second most amount of water in them is going to be ice caps and groundwater reserves. So groundwater is water that exists underground in saturated zones beneath the land surface. The upper surface of this saturated zone is called the water table. Contrary to popular belief, groundwater does not form underground rivers, and the aquifers that hold groundwater are not like giant caves. Now, there are some underground rivers that do hold water, but most of the water that's in our aquifers is more like filling all of the pores in between sand, gravel, and other rock that is underground, much like if you had filled a sponge with water in it. The groundwater flows naturally out of the rock and can be removed by pumping it. And so we pump it using wells. And that's actually the way that about half of the people using water for public supplies get their water. And about 40% of all water used for agriculture comes from water that's pumped out of aquifers. The rest would come from lakes or rivers. In the Kernersville area, the water is coming from Salem Lake. So when you are going to have a well, it's important to measure the water table, the uppermost limit of groundwater. So that would be as the ground is saturated, when you go from ground level, then you keep going deeper and deeper. If you were going to dig a hole, how long does it take before you reach soil that is saturated with water? And here it's about 15 to 20 feet deep. Then you will hit the water table. As we have water that is diverted through runoff and into rivers and streams, it's not able to replenish the groundwater that's in the ground and replenish aquifers. If we have really dry years, things like that can affect the water table. So when we look at conditions of drought, we often will look in wells to find out what the upper limit of groundwater is, or the water table, to make sure that that we're getting enough water in the area and we're not going to be running out of water. So groundwater trickles slowly through the ground. It's something like 3 to 25 inches a day into an aquifer or into that rock that's holding the groundwater. So in some areas that can be really, really ancient, even up to thousands of years old, where we used to have glaciers that covered the middle of North America in the Great Plains area now. As those glaciers melted, a lot of that water seeped into the ground and saturated the area into one of the largest aquifer in the world, which is called the Ogallala Aquifer. It covers across most of the Midwestern states. Okay, but we said that through this process that it's driven by the sun. So essentially we have water mostly in the oceans and in ice caps and glaciers. That water evaporates from the oceans, and then it goes through the process that you're familiar with, condenses into clouds, and then precipitates as either rain, sleet, snow, fog, dew onto the earth. When we have precipitation, we can also have things like snow melt runoff. That would be another example. There is also water in volcanic steam, but that's also going to condense really readily and come back down to the earth. So then it is able to filter into the ground or into freshwater streams, rivers, lakes, and eventually back into the ocean. So how are we impacting the water cycle? Um, well, for one thing, we are removing forests and plants, which increases runoff because those forests and plants help to stop the water from flowing as quickly. And as it trickles into the ground has more pores because the roots have broken up the soil more, and those roots can intake a lot of water. So that reduces the amount of water that's taken in that way. Also, when we don't have forests and plants, then we don't have as much transpiration. So the water cycle is impacted in that water is not transpired from the plants. Also, when we want to water agricultural fields, a lot of times they're pulling this water out of either rivers or lakes or wells. And so it's going to increase evaporation because as you spread that water over a large area and it's sitting on the surface, if the sun is shining on it, it's going to evaporate back into the atmosphere and then no longer be in the ground or in a river. When we are damming rivers, then we're changing the whole flow of the river. And secondary to that, it creates a large lake in an area on one side of the dam, which in turn increases evaporation because we have more water. The water is spread out over a larger surface area than it naturally would have been. It also infiltrates the area there a lot more because a lot more water seeps into the ground that would have naturally flown down the river. When we have pollutants that get into water, it can change the rain into acid rain or acid fog, which is called smog. But the most threatening impact that humans have on the water cycle is that we are using too much groundwater. We're just overall irrigating our crops too much. We are irrigating our lawns too much. We're using a lot of water for industrial uses like manufacturing of everything, and water that's used for drinking water. So the amount of water in an area causes huge conflicts because obviously water is another element that is essential, or not an element, but a molecule that is essential for life, just like the other elements and, maybe primary to us as humans, as we know how much we're made of water. So I hope that you are able to not only explain the basic steps of the water cycle that you learned earlier, but be able to describe where groundwater comes from and be able to determine what the major sinks are for water on the earth. And if you can do that, I think that you will be ready for a few more questions for practice on AP Classroom. Thank you.